Alright guys, welcome to this page of the notes, and again what we're doing is we're working with this idea of corresponding pairs of congruent triangles are congruent, CPCTC. But really before we do another example problem, I just want to real quickly go over the contrapositive. Now, contrapositive is a conditional statement we've looked at before, right? So just quickly refresh your memory on how the contrapositive works. If you're given a conditional statement, if P then Q, the contrapositive is going to switch the hypothesis and the conclusion. P is the hypothesis, Q is the conclusion. We're going to switch those guys. They're going to switch places, and in order to do the contrapositive, I have to negate both statements. So if I have if P then Q, I'm going to switch the P and the Q and negate both of them. So the contrapositive would be if not Q, then not P. Here's how it works. The contrapositive of CPCTC. Well, you can read it. In two triangles, if the corresponding pairs of sides and corresponding pairs of angles are not congruent, then the two triangles are not congruent, right? So in order to show that triangles are congruent, you just show that the corresponding pairs of sides and corresponding pairs of angles are congruent. In order to show that triangles are not congruent, all you have to do is show that one pair of corresponding sides or one pair of corresponding angles are not congruent. And then there's no way that those triangles can be congruent. So here we go. Let's quickly take a look at one of these. I got two example problems for you here. This is really kind of a simple idea, so I think we can get through these here pretty quickly. If I take this triangle right here and I just give it a little spinny spin, 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 this guy would spin around and lie right on top of this guy, so I know that RT and UV are corresponding sides, and based on the diagram, right, you guys know what those little hash marks mean. They mean that they're the same measure, right? They're congruent. So right away, just by looking at it, I know that RT is congruent to UW. I know that RS is congruent, right? If I spin this guy around, RS is congruent. Its corresponding side is WV. So WV. So I put my little segment line above there. And then that leaves me with the third side, right? Yeah, every triangle has three sides, so that would be TS. And the only other side left in this other one is UV. So TS is congruent to UV. Right? And again, that's information that's given to me right in the problem. So far, what I've done is I've shown that all three pairs of sides are congruent. So far, we're doing good. But now what about the angles? Well, again, if we give this guy a little spin, right, what I see is that R and W are corresponding angles. So, angle R, is it congruent to angle W? 71, 7, yeah, they are. Keep going. That would mean then that angle T, its corresponding angle would be U, right? 71, 71, yeah, those are congruent. Keep going. If I spin this guy around, lay these two triangles right on top of each other, angle S and angle V would be corresponding angles, right? Those are the two angles that would match up. If I spun those triangles around and laid them one on top of each other, S and V would be corresponding angles. Well, 38 and 38. So there we go. Those guys are also congruent. Angle S congruent to angle V. And what I've done by the theorem, CPCTC, is I've shown these two triangles are indeed congruent. All three pairs of corresponding sides are the same. All three pairs of corresponding angles are congruent, so the triangles must be congruent. In this next one, well, here's what I've done. Right off the bat, I have shown you, right, that BC, take this guy, flip him around, right? You've got to, flip him around, lay those two triangles on top of each other. BC is congruent, its corresponding side is EF, and they are indeed, by the diagram, shown in the diagram, They are congruent. So I'll write that real quick. BC is congruent to EF. Okay. Now that's all I'm told. I'm not told anything else about the other side. So we'll come back to those in a second. Remember, the contrapositive of CPCTC simply says if you can show that one pair of sides or one pair of angles are not congruent, then you've shown that the two triangles are not congruent. You only have to show that one pair of sides or one pair of angles are not congruent. Well, if I take this guy, right, and I flip him over, C and F are corresponding angles, and they're both the same, 60 and 60. But if I take this guy and flip him over, that means that B and E are corresponding angles, right? They have to be the same. But B is 41, E is 42. Those are not equal, so angle B does not equal angle E. Let's say that you didn't see that right off the bat. Let's say that you took this guy, right, and you flipped him over, C and F, corresponding angles, and they're the same, 60 and 60, so we're good. But let's say you looked at D and G, right? You flip this guy over, lay those two triangles on top of each other. D and G are corresponding angles. They would be in the same position. Well, D is 79, G is 78. That's not the same. Angle D does not equal angle G. So either way, doesn't matter which one, as soon as you show that one pair of corresponding angles are not equal, the triangles cannot be congruent. These triangles are not congruent. And again, the idea here is simply this. When you're doing these problems on your own in a homework or on a quiz or on a test, right? As soon as you get one of these, as soon as you find a corresponding pair of sides that are not congruent, or as soon as you find a corresponding pair of angles that are not congruent, stop. You're done. That's it. Once you find a single pair of sides, corresponding sides, or a single pair of corresponding angles that are not congruent, triangles cannot be congruent, you're done. Call them just, they are not congruent, move on to the next problem. All right, here we go. A really, really interesting theorem for you guys right here, this triangle sum theorem. And the reason we're going to get this triangle sum theorem is because we can use it to help us solve some problems, which I'll show you here in just a second. Here's what the triangle sum theorem says, actually a really, really important theorem. One that I think many of you, though, are probably already familiar with, simply says this: the sum of the measures, so that means you add the measures of the interior angles of a triangle, and it has to sum to 180 degrees. Every triangle has 3 angles, so this theorem is simply saying if you take the measure, oh, that's my highlighter, sorry. Take the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3, right? If you have a triangle, you add the measure of all 3 triangles, or you add the measure of all 3 angles, right? It must sum to 180 degrees. That's how triangles work. If those 3 angles don't sum to 180 degrees, you don't have a triangle. It's not a triangle, right? Triangle sum theorem. All 3 interior angles must sum to 180 degrees. Now, how does that help us? Well, here's how that helps us. We got an example problem right here. Let's go ahead, right? If I just take this triangle right here, N, M, and P, right? And I just bring him right on over and set him right on top of this guy, right? I've got corresponding sides, K, L, and N, P, right? Those are corresponding sides. And they're congruent, right? I got the 3 hash marks. N, M, and K, J are corresponding sides. And they're congruent. I've got the double hash marks on those guys. And MP, that side, MP, and side JL. Those are corresponding sides. And they're congruent because I got this single hash mark. So here's what that tells me then. Angle N and angle K congruent, or are corresponding and congruent, 45 and 45. M and J corresponding and congruent, 55 and 55. What I'm looking for is P. What is the measure of angle P and angle L? Well, here's where this triangle sum theorem comes in handy. I know the measure of two of the angles, and I know that all three have to sum to 180 degrees. So here's what you're going to do. You're going to take the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3, and you're going to set it equal to 180 degrees. Here we go. Angle 1, 45. Angle 2, 55. Angle 3, I don't know. That's what I'm trying to find. That's what I'm trying to find. Okay, well, it's equal to 180 degrees. So here we go. We're going to add these guys together. 45 and 55 should be 130. I'm not one, good grief, 130. How about 100? Okay, now I'm trying to solve, right? I'm trying to solve for this third angle. So I got to get it by itself. Well, it's a positive 100 degrees. So we'll just subtract that 100 to the other side. And so the measure of angle 3 has to be 180 minus 100. So the measure of angle 3, really pretty simple arithmetic there. I doubt you even need a calculator. 80 degrees. So this guy, right here, 80 degrees. That's an 80-degree angle. Now, here's what I know, right? Angle L and angle P, they're corresponding angles, and they must be congruent. They must be, right? I tell you, right, Sir? Congruent triangles. That's actually a really important statement. If these two triangles, right, if these two triangles are congruent, then these two angles have to be the same. If these two angles weren't the same, then the triangles couldn't be congruent. So these two angles have to be congruent, so I'll set them equal to each other. The measure of angle L is congruent to the measure of angle P. Well, plug in what I know. I know that the measure of angle L is 80 degrees. And the measure of angle P, 5x plus 3. I'm sorry, 5x plus 3. 5x plus 30. How about that? Awesome. Well, solve for x. Let's go ahead and subtract 30, right? It's a positive 30, so we'll subtract 30 to the other side, and I believe that's going to leave me with 50. Divide both sides by 5. And we get x is equal to 10. So I want you to find the value of the variable that results in congruent triangles. In order for them to be congruent triangles, these two angles have to be congruent. So I'll set them equal to each other. I found this angle by doing the triangle sum theorem. I know that this guy has to be 80, right? All interior angles must sum to 180. That allows me to then take 80 and set it equal to, right, the other angle that I didn't know, 5x plus 30, and solve for x, we get 10. I don't know why I put it in red. That's one of my final answers. I'll put it in green. Anyway, there we go. I got another one of these for you on the next page of the notes just to get a little bit more practice. So here we go. Let's go ahead and try this one. Again, same thing. I want you to find the value of the variable, that results in congruent triangles. Again, congruent triangles tells me that all three sides, all three pairs of congruence, or all three pairs of corresponding sides must be congruent, and all three pairs of corresponding angles must be congruent. All right, well, let's take a look at what we've got here. Okay, in order to lay these triangles on top of each other, I'd have to take this triangle, flip it over, right, and then just drag it over and set it on top of this guy. So angle A and angle D are corresponding and congruent because they both have that single little arc in there. It tells me that they're congruent. C and F corresponding and congruent, the double arc. B and D, right? If I flip this guy over, B and D would be corresponding angles, and I can see from the diagram that they are congruent. So then what does that tell me? Well, it tells me that A and C is, its corresponding side is DF, and indeed I can see 50 millimeters and 50 millimeters, so those definitely match up. In fact, let me put my little, those guys are the same. Which then tells me that BC, its corresponding side must be EF or FE, whichever way you want to say it. And indeed it is 30 millimeters and 30 millimeters. So double and double. Which leaves me with one pair of corresponding sides left, AB and DE. Well, I want these triangles to be congruent, so that means that those two sides must be congruent. I know that side AB must be congruent to side DE. Well, let's go ahead and plug in what we know. I know that side AB is 36 millimeters. I know that side DE, 2y plus 20. Well, let's go ahead and solve for y. In order to do that, I think I'll subtract 20 from both sides, which is going to give me 16. Okay. To get that y by itself, I'll have to divide both sides by 2, which means that y is going to be equal to 8. Well, let's go ahead and just check our answer real quick. Here's how I'm going to do that. 2y plus 20, right, needs to be equal to 36, right? These two sides have to be the same. Well, let's just check it and see. I'll drop an 8 in there for y. 2 times 8 plus 20. That's got to be equal to 36. Well, 2 times 8 is 16. And indeed, 16 plus 20 is 36. So our answer, y equals 8, checks out. When I put it in there, I do indeed get 36, which is exactly what I need it to be. And 1, 2, 3. Those two sides are congruent. All right, guys, here's the big sort of takeaway then from this set of notes in these videos. CP, CTC. Corresponding pairs of congruent triangles are congruent. If you can show that all three pairs of sides and all three pairs of angles in a triangle are congruent, you have shown that those two triangles are congruent. All you have to do is find one pair of side or one pair of angles that are not congruent, and the triangles cannot be congruent. All right, that's really what you want to take away as we continue going through sort of this idea here about talking about congruence of triangles. We'll dive into that a little bit deeper and find other ways to prove that triangles are congruent. I had a great time sort of taking a look at this idea with you guys, this CP, CTC, and I can't wait to see you next time. Bye.